Back. You must be getting sick of the sound of my voice by now. I'm hoping that you're sick of the sound of my voice by now, because that will mean that you've actually been doing a lot of study. This film is going to be about the arc length and perimeter of a sector. So this is all about the wonderful shape that we've all grown to love, the circle. So what we're going to do with our circle is we're going to first of all discuss what a sector is. So if you were to think of a circle as a giant piece of pie, or a giant pie, sorry, a sector is like a slice of your pie. So I've just drawn a sector there, okay? And depending on how big a slice of pie you want, you can have different size sectors. The thing that makes this a sector, of course, is that all of these lines that are leading away to the outside of the circle, to the circumference, are all coming from the center, okay? So that is what a sector is. So if I was to give you a sector, and say I said I'm going to take less than 90 degrees, obviously, this is going to be about 60 degrees, and this is all, these are radiuses, okay, and r is equal to, let's make it 8 centimeters. So both of these would be the same because the radius is not going to change. So both sides of the sector are always going to be a radius. And were we to actually increase this out, it would become one big part of a circle. Okay, so that is a sector, and this is the center of the circle. So our slice of pie, and this part of the circumference is called, it's part of the circumference, it's called an arc. So if you were asked to calculate the length of that arc, it's obviously going to have something to do with circumference, okay? Now we all know from previous videos that the circumference of a circle, C, which is the distance all the way around the circle, is equal to 2 times pi, that magic number, times r, the radius, okay? So we have all the information we need to work out the length of that arc, because we've got this angle here. Now, if it was a full circle, we could work out the entire distance around the circle by saying 2 pi r, but it's not the whole circle. It's a fraction of the circle. Now, you might be saying to yourself, well, how do I work out what that fraction is? Well, we're going to use two pieces of information that we know. We know that the angle in here of this sector, okay, is 60 degrees, and we know, or we should know, we will know after this, that there is 360 degrees in a circle. So if we put the 60, if we want to work out arc length, it's going to be equal to the 60, I'm going to write here arc, L, which is arc length, is equal to 60 over 360 times 2 times pi times r, which is 8. And that then gives us, we can cancel down our zeros, because it's a fraction, and we can also divide the top and the bottom by 6 in this case, so we can say arc length is equal to 1 over 6, because 6 over 36 is 1 over 6, times 2 times pi times 8. And if I had a calculator handy, I would be able to work that out. So what I'm going to try and do is get myself a calculator. So just bear with me for 1 second while because I'm always so organized, as you well know, and I'm just going to grab our trusty calculator, and we're going to try and work out what that actually equals. Okay. So we've got our calculator up on the screen. Well, I've got my calculator, you won't be able to see it. So we've now got it's going to be 2 over 6, which is 1/3. So we're going to say, we'll just get this all cleared up. So 1/3 times pi times 8. And the answer comes out to 8.377. So I'm gonna do that to 2 decimal places. So 8.377. The 7 is 5 or greater, so this is going to be rounded up to 8 because that is that critical digit. Just a little bit of practice at our rounding of a number. So this will become 8.38 centimeters. Okay, so we now know that this arc length is 8.38 centimeters because we've used this formula to work it out. So it's always going to be a percentage of 360 multiplied by our normal formula that we use to find circumference. So we now know how to find arc length. If the question was just asking you for arc length, that's how you would do it. If you needed to find out the perimeter of the sector, you would need to calculate this arc length, and then what would you need to add to it? Well, you'd need to go around the sector, so you need to go down one radius and then up another radius. So you'd have to add 2 times r. So if it was the perimeter of this sector, which is this slice of pie, we would have to add our 8.38 to 16 because you need to add that radius and that radius to go around. So you'd add another 16 onto it, and adding another 16 onto it would give us 24.38. So perimeter of a sector is equal to 24.38 centimeters. So now you know how to find arc length and also the perimeter of a sector. I'm just going to show you in a generalized form how that formula actually, or what that formula actually looks like. So if you have a giant circle and you've got a sector, let's say that's, we're going to call that theta. It's just a way of naming an angle that we haven't got a value on yet, okay? So it's a variable that you can put into a formula. So that's theta, okay? And we can say arc length is going to be equal to theta, which is that angle, over 360 times 2 pi r, okay? Which is just what we did. So 2 pi r is our circumference formula. You can also say pi d. And theta over 360 is the way of working out that fraction of the whole circle. And we know that if we were to make theta the whole circle, it would be equal to 360 over 360, which of course is equal to 1, because anything divided by itself is equal to 1. And we'd have just our normal circumference formula. So the closer we get to 360, the closer we get to 1, and the closer we get to the full circumference, okay? So arc length actually becomes a circumference when you have a theta value of 360, which is the whole circle. If I make it 180, it'll be half the circle, so we'll have half the circumference. So if I was looking at this as a sector, and we had 180 degrees, then I would know it's 180 over 360, which is equal to a half, okay, because it's half the circle. So we would have half of our circumference. So you can see how that formula works. The bigger the angle, the more of the circumference we're going to be looking at. So that is how you work out the arc length, and also how you would work out the perimeter of a sector. I hope that's been of some help. If you're a little bit confused by that whole scenario, please come and see me at school and we can discuss it further. But there's also very good examples in your book as well, in your textbook. So I would advise you to really have a good look at that work in your textbook. And please, like I said, come and see me if you have any difficulties with this concept, because a little bit more explaining and a little bit more practice, I'm sure it will make perfect sense. Anyway, that's me on arc length and also working out the perimeter of a sector, and hope that's been of some help. Keep studying.